Computer science. We're going to talk about modeling systems. This is the nature of object-oriented programming, which is what we do in Java when we program in Java. So consider you want to write a program. You want to write the point-of-sale system for McDonald's. So here you go. At some point in time, this was the point-of-sale system for McDonald's. So what you would do is you would break this program down into pieces, and those pieces are objects. So you think of what kind of things are here and how do they interact with each other. So we've got an order. So one of the objects we might have in this system is an order. And let me say that there's not necessarily one right way to do this. You could break a problem down into different sets of objects depending on how you visualize this project working. So there's usually many different correct ways to solve a problem like this. We're just going to talk about one of them. So we have an order. So that would be an object that keeps track of ordery stuff. There's a menu. So you have a menu of all the options that you have to purchase or to sell. You have menu items. So a menu is really made up of a collection of menu items. A menu item would be one thing you could buy, a soda or a fries or a burger, a specific item on your menu. There's an employee object. So this is the information about like who has logged into the system, who's using it. And then the whole thing, all these objects together are kind of put together into a point of sale system object. So the whole program, kind of this big encompassing thing. And that's made up of that, figures out the relationships between orders and employees and menus and menu items. Each one of these objects, once you've decomposed a program into a bunch of objects, you would write classes for each one of these objects. So you get public class point of sale system, public class employee, public class menu. All of these are stored in their appropriate .java files. And then you'd go through and you'd write what's the behavior for these objects, what are the attributes for these objects. So you'd say to yourself, well, what does a menu item know about? It knows the name of the item, it knows the price of the item, it might have a picture of the item in it. An order might have an order number. It would have a list of the menu items, the things that are in that order. And then behavior, what can a order do? Well, you could add items to your order. You could calculate the total. So what's this person have to pay? You could send the order to the kitchen so people start actually putting the food together to give the order. You could print the receipt so that you can give that to the customer. So these are the behaviors of an order. You'd write methods for those. The point of sale system might have behavior like the ability to log in or the ability to start a new order or the ability to log out. So these are all the things. For each one of these objects, you'll have to come up with what are the methods that it needs and what are the instance variables that it needs, what's its behavior, what's its attributes. That being said, when you're writing code, at any particular moment, you're only thinking about one class and one method in that class. That's all you have to focus on. I'm trying to solve the problem. How do I calculate the total of an order? That's it. Solve that problem, move on to another method, solve that problem, and until you've written all of the methods. But you're not writing all of it at the same time in one moment. You're just solving one little problem. And once you solve all of the little problems, you'll have solved a big problem using all of those small solutions. So now you've done it. You've written all of these classes. You've got all these Java files with all of these classes in it. Somewhere in your program, you'll have a method called public static void main, string brackets args. This is a magical method. This is where your code starts. When you hit run, this is the code that runs. And this code will use all of these objects you created to get that program started and actually do something. So all of these classes that you created, all these things do is define what they do. What does a menu do? What does a menu item do? What does an order do? They're just definitions. But the main method, this is what actually makes something happen. This is saying, in this example, it's creating some menu items. It creates some fries and some nuggies. It creates a menu and it adds those items to the menu. It creates a point of sale system object. it adds the menu to the point of sale system. It asks the user to enter their employee ID, and then it logs in that employee to the point of sale system. And there would probably be more code to display all of the menu on the screen so you can touch the buttons and produce an order and a receipt and whatever. But this is the code that actually makes stuff happen. But before you can do the main method, you'd have to actually decompose the problem into objects and then define what those objects can do and what they know. What are their behavior? What are their states? So if you're trying to write a program in Java, how do you do it? You got to think of the problem you're trying to solve, break it down into objects. What are the different objects in this problem? How do they interact with each other? What do they do? What are their behaviors and attributes? What can they do? What do they know? And then for each one of these objects that you think about, you have to write a class for that object. You have to write the methods for those objects, and you have to write the instance variables for them. And then you write a main method that puts everything together, that actually creates instances of the objects and calls the methods and makes them actually do things. These two steps, step 3 and 4, this is what you're going to get tested on the AP test. So sometimes you will have to write an entire class from scratch. Often you'll be given the class and you'll just have to implement a specific method or maybe 2 or 3 methods of the class and just write the code within the method. So this is really all you have to focus on for the AP exam. Step 5, this is where you would write scanner and print line code. And this is very important to remember. The AP exam is going to cover steps 3 and 4. Step 5 is where scanner and system.println go. That means on the AP exam, you should not write scanner code. You should not write print line code because you won't be in that level of writing a program on the AP exam. You'll actually lose points if you write scanner or print line on the AP exam because they're only asking you about writing classes and writing methods for those classes. Now in the labs, you have to do this part, but also when you're writing the test code for your labs, that's where you're in part 5. This is where your code that tests the objects you create goes. And that's why you write scanner and system print line in your labs. It's to actually make that whole program run. But when it gets to the AP exam, all you're going to have to do is write methods and classes. So it's less for you to do, right? No print line, no scanner. And that's computer science.